Hello science fans. Today we're going to explore a truly amazing idea where we can use plants to solve a very modern problem. Imagine your phone, your tablet, or an electric car. They all need batteries, and those batteries need metals like nickel. The problem is, getting those metals out of the ground can be a messy business. Traditional mining often means digging huge pits, using powerful chemicals, and creating a lot of waste that can harm our planet. This process can lead to deforestation, pollute our water, and release greenhouse gases that warm our world. It's a big challenge for a greener future. But what if there was another way? What if, instead of digging deep into the earth, we could just grow what we need? This is the core idea behind a science called phytomining. The word phyto comes from the Greek word for plant. So phytomining literally means plant mining. It's a process where we use special plants to pull metals right out of the soil. These plants act like natural vacuum cleaners, sucking up metal particles through their roots and storing them in their leaves and stems. It's a fascinating blend of botany and engineering. This concept isn't entirely new. For decades, scientists have used a similar method called phytoremediation to clean up polluted land. For instance, after the Chernobyl disaster, scientists planted Indian mustard plants to help absorb radioactive elements from the contaminated soil. Phytomining takes this idea one step further. Instead of just cleaning the soil, we are harvesting the plants because the metal they have collected is valuable. It's like turning a cleanup job into a treasure hunt, where the treasure is essential for our modern technology. The reason this is so important right now is because our demand for metals is skyrocketing. Take nickel, a key ingredient in the batteries that power electric vehicles. As more people switch to electric cars to reduce air pollution, we need more nickel than ever before. Experts predict that by 2040, our need for nickel could increase by nearly 70%. Phytomining offers a potential way to meet this demand with a much smaller environmental footprint, turning otherwise barren land into a source of valuable resources while being kinder to our shared home, planet Earth. So, how exactly do these plants do it? It's not just any plant that can perform this amazing feat. The stars of phytomining are a special group of plants called hyperaccumulators. These are plants that have evolved a remarkable superpower. They can thrive in soils that are toxic to most other plants because of high concentrations of heavy metals. Instead of being poisoned, they absorb these metals and store them in their tissues. There are around 700 known species of these incredible green miners, each with a preference for different types of metals. These plants didn't develop this ability to help us build batteries, of course. Scientists believe it's a clever defense mechanism. When a plant's leaves are filled with something unappetizing like nickel, insects and hungry animals are less likely to eat them. It's like making yourself taste really bad so nothing will bother you. The metal gets stored in the plant's leaves, shoots, and sap, sometimes reaching concentrations of up to 2% of the plant's total dry weight. That might not sound like a lot, but for a plant, it is an incredible amount of metal. A great example is a type of plant called Alyssum murale, which is a fantastic nickel hyperaccumulator. These plants are often found growing naturally in areas with nickel-rich soils, known as serpentine soils. These soils are often rocky, thin, and not very good for growing food crops, which makes them perfect candidates for phytomining projects. When alyssum is planted in these fields, its roots go to work, drawing up nickel from the soil. The plant then transports the nickel up to its leaves, where it is safely stored away. Other plants are specialists in different metals. The alpine pennycress is known for its ability to accumulate zinc, while some types of ferns can absorb rare earth elements like neodymium, which is used in powerful magnets. Macadamia trees, famous for their delicious nuts, are also surprisingly good at absorbing manganese. Each of these plants opens up a new possibility for sourcing materials in a more sustainable way. By understanding these natural processes, we can partner with nature to harvest the elements we need for our technology. It's a wonderful example of applied science. To see phytomining in action, let's take a trip to a real-world project. In northern Albania, a company called Metal Plant is running a fascinating test on a 10-hectare field. The soil there is naturally high in nickel, containing about 0.2%, but it's not suitable for growing food. This makes it a perfect laboratory for metal farming. The team at Metal Plant plants a nickel-loving hyperaccumulator across the field. For a whole season, the plants grow, soaking up the sun, and, more importantly, soaking up the nickel from the ground beneath them. It looks just like a regular farm, but the crop is metal. Once the plants have reached their peak growth and are full of nickel, it's harvest time. The plants are cut down and left to dry out. As they dry, their nickel concentration increases to about 2% of their weight. Then, the real processing begins. The dried plant material, now called biomass, is carefully gathered. It is then burned in a controlled way. This isn't like a regular bonfire. The goal is to burn away all the organic plant matter, the leaves, stems, and stalks, leaving only the inorganic material behind. This resulting ash is what they call a bio-ore. This bio-ore is where the treasure lies. It's a fine powder that is rich in nickel. The next step is to extract the nickel in a usable form. The ash is treated with sulfuric acid, which dissolves the nickel and allows it to be separated from the other elements in the ash. The final product is nickel sulfate, a high-purity compound that is exactly what battery manufacturers need to make the cathodes for electric vehicle batteries. From their 10-hectare site, Metal Plant reports they can harvest over 3 tons of nickel in a single season. This process is designed to be much cleaner than conventional mining. For one, it avoids digging massive holes in the ground. Furthermore, the company is experimenting with adding crushed rocks to the soil, which helps the plants access more nickel while also capturing carbon dioxide from the atmosphere. This allows them to sell carbon credits, adding another source of income. This project in Albania is a small-scale proof of concept, but it shows a clear pathway from a field of green plants to the high-tech components powering our future. Now, this all sounds fantastic, but we have to be good scientists and look at the whole picture. Can phytomining really replace traditional mining? The biggest challenge is scale. A conventional nickel mine can extract 3 tons of nickel, the amount the Albanian farm produces in a whole year, in about half an hour. To replace the world's current nickel production with phytomining would require a massive amount of land, perhaps as much as 15 million hectares. That's an area roughly the size of the entire state of Illinois. Finding that much suitable nickel-rich land is a major hurdle. There are other challenges too. Because phytomining is a form of farming, it faces all the same risks. A crop could be wiped out by pests, disease, a sudden fire, or a flood. Large-scale monoculture, planting just one type of crop over a huge area, can also have its own environmental impacts, potentially requiring fertilizers or pesticides. Furthermore, the metal in the soil is a finite resource. After about 20 years of continuous phytomining, the nickel in the topsoil would be depleted, and the farm would no longer be productive. We also lack the industrial factories needed to process a huge volume of plant biomass. Despite these significant obstacles, interest in phytomining is growing. Just a few years ago, analyses showed it wasn't profitable. But with the price of nickel rising and the push for secure domestic supply chains, the economics are changing. In 2024, the U.S. Department of Energy invested $10 million into phytomining research. This is because over half of the world's nickel comes from just a few places, creating fragile supply lines. Developing alternative sources at home is becoming a matter of national importance. So, what does the future hold? Phytomining is unlikely to replace conventional mining entirely. Instead, it will probably work alongside it as a supplementary source of metals. Its greatest potential may lie in smaller, community-based projects in places like the Balkans, Turkey, or Malaysia. These projects could allow local communities to earn income from land that can't be used for anything else, all while cleaning the environment. If we can solve the scaling challenges, plant-based mining could become a key part of a greener, more sustainable world in the coming decades. It's a powerful way we can work with nature to build a better future for everyone. Consider the possibilities.